Hello. All right. Okay, everyone. We're about 5 minutes early. We're going to start right at 9 a.m. Pacific. Let's see here. We're just waiting for a few more people. Okay, looks like we got a bunch of people online. This is good. Thanks for coming. I know it's early on the West Coast. Let me know if you can't hear me. Typically, I recommend dialing in to the phone number. The audio is a lot better and a lot more stable. So you see, I'm cleaning off my list here of browsers I had open for the last few days. Okay, let me pull this up here. I could share my screen here in a sec. Okay. All right, only got those. Okay, I just got word from the other guest speaker who works for Red Hat and had a customer thing come up that he's jamming on right now. So I'm going to describe the projects that the PipelineAI stuff uses, and then that'll kind of set up the context for next month when we'll have him back on the line, actually doing demos and that kind of stuff. I said, don't worry about it. I can do the higher level stuff since we use the projects. And then he's one of the guys that actually works on some of these. And they're mostly around Kubernetes. And let me pull up the first one here, for example. Fabricate. This is one that I've stumbled upon. I actually don't use the Fabricate sort of development platform or the developer IDE or whatever kind of thing they have here. I just use a lot of the Maven components that they built. Fabricate's really cool. These guys spend a lot of time working with Kubernetes. They've because of their like OpenShift product and things like that, public cloud type things, they've relied heavily on Kubernetes as the orchestrator. So there's a lot of videos, a lot of blogs. They actually spent quite a bit of time at the end of last year. I had spoken with them and kind of gave them my feedback, my experience. Trying to use it out of the box was a little bit wonky. It's just one of those classic, there's so many moving parts and there's so many different ways to use Fabricate that it was kind of overwhelming. And I just told them what my simple use case was, and now that seems like they've simplified the core features quite a bit. And then you can then add in these extra integrations. And a couple integrations to point out, I do tend to use a lot of their Spring Cloud and Spring Boot stuff. What's good about this is it brings Kubernetes into the Spring Cloud way of doing microservices. I like to keep things thin, but I don't want to be rewriting my own service discovery. And so there's a certain point when you just want to choose a different tool that's been tested that you don't have to maintain. And these guys have done a great job. They also have something called Funktion, Funktion. Now this is this is Lambda style programming, similar to the Amazon Lambdas, that's where that term comes from, on top of Kubernetes. So this is cloud agnostic. It crosses hybrid cloud. So there's a lot of cool stuff that you can do with functions. And the way we use it for some of our model deployments is, think of when you're deploying code as a function, how simple that is. You just push it out, either in like a Docker image or right inside of the Lambda, dialog box or whatever you want to think of it, where you're physically getting the code, the Python file or the Java code into this Lambda, and then it can be scaled essentially infinitely. So instead of code, we're deploying models, rather with a little bit of code to actually call the predict method and to like initialize and transform any JSON variables into NumPy variables, things like that. So Function's awesome. Really, really like it. The other integration that's worth highlighting is the KubeFlix. So as you guys know, my background, I was with Netflix back in the day when I first moved to the Bay Area from Chicago. That was my first job, and I got really used to a lot of the key Netflix open source components like Hystrix and Ribbon and like Turbine, and these are when you start to scale and start to have many of these microservices that are talking to each other and that depend on each other. It's a way to sort of inject cluster stability into your system so that one service can't take down all of your services. Okay? I was directly at Netflix when we were putting these things in, and saw the uptime percent go up greatly. Just and of course client satisfaction. And so there's times when these circuit breakers and things have been popped open or tripped, and that puts the end user in more of a degraded state. So from and then lets the system can then recover, or we have time to go in and scale out one system or scale back another system or cut over, or whatever we have to do that would require manual failing over stuff. So there's also Chaos Monkey that they throw in there, which is a way to kind of artificially induce some of these problems, and Latency Monkey, where you can inject 5-second latencies and make sure all of your timeouts. And so they spend a lot of time doing that. Of course, they have the Slack integration and all the stuff you would normally expect to see. They have Grafana and Prometheus, and yeah. So Fabricate's really cool. If you check out, the other couple to look at would be Funktion, KubeFlix, and the way I would find these projects is I would literally be like, I'm looking for Netflix circuit breaker pattern on Kubernetes, and it would be like the first or second project, and and I just kept seeing them over and over. And Maven Central, I was seeing jars with the name Fabricate in it all the time, and I was pulling down and testing, and so it's the whole serverless thing is this function business, but very easy to get up and running. You can create your own Docker images that then participate in this function. All you have to do is give it, I think, like a run method, and now you have now created your own function that you can deploy and scale. All right, let me head back to the Spark. All right, I was getting stuck there. Thank you, Xfinity. Okay, so yeah, so for anyone that just came in late, Christian is actually going to speak at the next one next month. So we'll circle back with him. I just gave kind of a higher level overview. And then I want to now move in to cover some of the things we've been doing with PipelineIO. Actually, we've now renamed it PipelineAI, which was probably no surprise. I kind of went back and forth with the name. I like the sort of traditional nature of PipelineIO. I spent quite a bit of money getting the domain name, but also have PipelineML, PipelineAI. So mainly after doing a little A/B testing on LinkedIn and changing it from IO to AI and seeing the type of interest that was being generated, I just right now currently the current trend is AI, and yes, as we all know, and you kind of get some instant street cred when you have AI in there. So I think we're going to roll with it. In fact, yes, I know that we're going to roll with it. So I have to update some of the logos, which I needed to do anyway because these logos were kind of thrown together quickly. But yeah, so I've also mentioned one of our first products coming out is going to be called DeployAI, and that's going to focus more on the deployments. We also support training, so that will likely stick with the traditional PipelineAI name. But really want to drive home the fact that this is a company focused around AI and AI deployments. So that's why we would reinforce deploy. We're recording this, and then I want to go. So actually, we should be able to go to PipelineAI, and that should redirect. Let's test it right now. Yeah, so it goes to PipelineAI here. So let me zoom in. We got some recent news here. I think since the last time I spoke with you guys, we made the keynote at the Spark Summit. One of our customers, Hotels.com, that we work with pretty closely. I was in London a few weeks ago. I spoke at a meetup there. We were talking about how to get PipelineIO in there for these deployments. And they like the sort of testability of things, the ability to build the same model in R and scikit-learn, in TensorFlow, and even Spark, doing the same linear regression or like whatever, deploying it to the 3 or 4 different runtimes and then load testing. And then throwing in GPUs as well too, right? So some of these runtimes do support GPUs, and that was very interesting for them too. So some of their models, they're using like recurrent models, and with huge payloads, 50 megabyte payloads, things like that. So we've been working with them, especially they've got some really cool use cases, really real world use cases, and working to get them onboarded onto PipelineAI. The other thing, I think I maybe expanded some of the tour stuff here. There's all the languages, XGBoost, any sort of ad hoc Python. One thing we've been getting a lot of requests for just in the last couple of weeks is being able to deploy just key value pairs. And so we support Redis and Cassandra right now. And what this lets you do is essentially do offline training and generate, product recommendations. So in machine learning speak, for example, in Spark ML, you would build so you would use collaborative filtering, and you would use something like Spark ALS, so alternating least squares. And what you're doing is the output is a bunch of user factor matrices and then item factor matrices. And you can either go through and sort of pre-calculate, for this particular user, these are the top 100 items, and store them in just a flat database, right? Just a simple, key value store, right? So things like Redis, things like Memcache, things like Cassandra, these are great for this kind of stuff, right? This doesn't have to be in memory, but if you really, really want to get the most, the fastest response time, you would want to go with something like Redis. If you're a little bit more cost conscious, you probably want to stick with something on disk, and just know that there'll be latencies typically, and the maybe sub 10 millisecond, but with Redis it's near, it's typically below 1 millisecond, so sub 1 millisecond, which is really nice. We're also, a couple people have been asking about custom ensembles. I'm actually seeing this more and more on the TensorFlow side, and where you use this feature within TensorFlow serving that's called multi-headed inference. And multi-headed inference is where you pass your inputs in, and you actually get 2 types of responses. The first response you get is whatever classification that model is giving you. The second response is sort of, if you think of it like the last layer in your neural network that contains values that you then want to pass into the next model, and you sort of want to chain these together and ensemble them together. So people are doing this, if they have 3 different versions of the same model, they want to essentially, sort of average the, final result. And if there's 3 models that are giving all the same, similar results, then you feel pretty good about the final prediction. In terms of training and, tools, this is the sort of tongue-in-cheek pancake stack, something I created I think about a year and a half ago now, and it has traveled with me throughout my travels in Europe. People know me as the pancake guy, which is kind of funny. So all of this is available. I've been slowly turning on these features within Community Edition. I've been trying to keep Community somewhat small with a relatively small surface area, mainly for support reasons, mainly for stability. I just want to make sure, as we add new features into the free version, that people, that the system, right, like still maintains stability, right? Because this is multi-tenant system. Could be some cases that we're not thinking about in terms of memory usage, and we're trying really hard to get GPUs in. In fact, I'm pretty sure by the time I talk to you guys next month, we'll be talking more about GPUs in Community Edition. So that will be exciting. Everyone will get, like 100 free hours or something like that of GPU. But yeah, you'll probably recognize a lot of these tools. Presto, you have a Hive Metastory of HDFS. A lot of my demos these days are with Jupyter Notebook because they're very easy to share. Data scientists seem to like that at this time more so than something like Zeppelin or right, like a Databricks kind of thing. They like the standard Jupyter Notebooks. We actually do have a demo of this natively generating code. So we take your Spark model, for example. This is going to be a really cool demo. We then generate native Java code. And we then deploy the native Java code just like we would like any other kind of function, in a serverless manner. And we can do some really cool, like optimizations there. So yeah, looking forward to hopefully showing you guys some of that. Deploying the model, like I said, we're currently working on tooling where it will be as simple as just clicking deploy this to dev, deploy it to prod, maybe roll it back from prod. This is kind of an oversimplification, and you can turn this on and off. Like you don't necessarily have to let your data scientist directly from production deploy. This makes a lot of people nervous. This was the freedom I had seen with like Netflix. So Netflix gave us, the developers, the freedom to deploy code out to production. And as long as we had proper tooling to roll things back and to monitor, we would first push out one canary, see how it was doing. It was getting live traffic. And the whole goal of PipelineAI has been to bring this sort of freedom and responsibility, of course, to data scientists, and to let them sort of have a view into production, to let them in a somewhat controlled manner, they can actually start their own experiments. They can keep an eye on them. So all the things that you would expect from something like a Google Cloud ML engine, this is the type of thing that we're bringing in. Because we use Kubernetes, this is now hybrid, so it's cloud, can run on the cloud, can run on your open stack cluster, can run on-premise. Basically, wherever Kubernetes is supported, you can plug in to PipelineAI. So yeah, that's kind of the, in fact, I'm working on a pretty cool demo for a potential customer tomorrow that we're pretty excited about. Okay, so yeah, these are the different types. Here's the main way that we right now interact is through this command line, right? Like again, we've got some we go back and forth on how complex we want a separate UI to be. We've seen a lot of the competition, we know what they're building. Yeah, we've talked to them directly, and me and my UI guy, my buddy John, we've been kind of going back and forth on the simplest design, and so we're kind of leaning towards keeping this sort of Jupyter integration, but at the same time making sure that the JavaScript can be reusable. Looks like Jupyter's actually using TypeScript in quite a few places, so that was good news to us. We just realized that last week. So we like TypeScript, we like typing, we like being able to write tests, things like that. So I think the first iteration will likely be JavaScript that comes in the form of buttons or drop downs here where you can see the model engines and You can scale the model engines with just a quick, right, you can just right click on it and say, give me 40 more of these prediction servers, like TensorFlow prediction servers, that kind of thing. So those will be the next demos coming. We'll also have, GPU-based model servers, so we can finally prove or really disprove if GPUs are valuable on the prediction side or if they're only valuable on the training side. So we're going to be doing quite a bit of side-by-side benchmarks coming up here soon. And of course, posting all the results. Real quick, if you haven't seen it, here's Community Edition. Click over and get to it a few different ways. We chose this sort of orange background. It kind of matches TensorFlow's orange background. I have to clean this up heavily, but for right now, you can get over here. You can look at the GitHub, we're up to almost 1,700 stars. We have 10 plus thousand Docker Hub downloads. So we're definitely kicking butt on the open source side of things. So if you click here, you can train and deploy. This gets you right into PipelineIO. I've changed that to AI. PipelineAI branded Jupyter Notebook. I cleaned this up pretty heavily too. So before, all of the models were being represented here, and there was, XGBoost and ways to get things from Spark into TF record, which is TensorFlow's sort of sequence file. If you think of sequence files back in the Hadoop days, TF record is sort of TensorFlow's desired format. So there's ways to get stuff in there, but like a lot of this stuff has not been promoted up to sort of first-class demo, whereas these three were the first ones I started with just because it's what customers were asking for. And there's ways to step through here and get started and just, sort of follow these steps, 0, 0, 0, 1, 0, 2 to actually get it out there. So this is sort of free-form Python. And let me just get to the good stuff here. Here's how you train the model. There's a bit of boilerplate right now. That's what we're trying to simplify and trying to, code gen and instead of having people copy and paste this stuff all over. There's, think of it like there's a pipeline, really AI sort of framework that your model really if you're just focused on the model, which is the goal for this, you would just write this predict method, and you would just write these transformers here. So you would write basically 3 functions. This is how you get the data from JSON into a dictionary or like a NumPy array. That's on the inbound, and then you create this like response transformer, which takes the output. So it would be like a TensorFlow prediction protobuf, and it would convert it into JSON to get sent back. So this is code. Right now, we're including this inside of the function. There's been some back and forth on whether or not we have the client actually get it into the format and do the response and the request transformations. But for now, we're just kind of keeping it this way because there's already some people using it. So maybe for V2, we might actually give the option to just pass in just the predict method, and then it's assumed that you've already got the value that you sent us can be automatically serialized somehow. So, and it's more than just serialization, though. It could be doing some conversions and things like that. There could be business logic in those. It's typically JSON parsing and then aggregating. So yeah, there's a version there, and then once you pickle the model, now it's pickled, and that pickle is part of the bundle that gets. So here's the pickled file. Here's some requirements txt, anything needed by this model, like NumPy, like JSON, things like that. So, and then deploy the model. So to deploy the model, this is where you can use the PIO command line and just run it within Bash here. This is definitely something that is going to be replaced with, in like one of the photos there, I was showing a button right above the cell, or maybe kind of like an upload to PipelineAI thing here. And it would, it would basically run this in the background and then push out the bundle. So here's the bundle that gets created, and there's ways to do like pass like sort of like a git ignore function or file, and inside of it'd be PIO ignore something like that, and it can keep certain files out from being because here it's actually pulling in. It's bundling up the notebooks as well and pushing those out to the model deployment server. All right, so this model was deployed successfully. Now we can call PIO predict. So let's jump over to the next. There's the predict notebook. So here we're just initializing. I always put this at the top of the notebook in case you're sort of jumping around and kind of remind you of the context. But when you first initialize, you kind of want to state everything that is known about the model. That way, when you do go to upload it, the model servers, like deployment servers, know where this thing belongs in the taxonomy. And you can actually have multiple versions. You can use GitHub hashes here for your versions. Some of this in the more formal advanced edition, this will be part of like real pipelines, real model deployment pipelines going through Jenkins and building Docker images. And the goal there is every model that gets deployed, each version of that model gets deployed into a single Docker into a single Docker image. It gets burned into the single Docker image, so you have full traceability. So and you'll upload to Docker Hub or to Quay or to Google Registry, and you can tie everything back and say this model was built with this code, it was built with this data, and so on and so on. Okay, so let me just run this here. Hopefully this model's out there. And we can run, yeah, so this is just a little small JSON file with some sample data in it, and we have, there's the response there. We could do this cool thing where I could just do like a quick little mini load test, and this is nothing big. This is just using Python and spinning up multiple processes in parallel, and just kind of gives us an idea. This is not a full or totally controlled benchmark, but maybe the version 0, for example, maybe these total times were taking 10 milliseconds, and now it's consistently up to around 12.5, 13 milliseconds, 15 milliseconds. That would be cause for some sort of alarm, like, okay, maybe my model is taking up probably more time than it did before. Maybe I deployed a deeper neural network. One thing that we're adding to the responses that is going to be huge is the ability to turn on how much time is being spent, capturing how much time is being spent in the transformation layers. So for the request and the response, for the actual prediction itself on the model, any sort of load times for dependencies, things like that, all that stuff, we want to give insights into the caller. There's a tiny bit of a performance hit, so it's definitely going to be something that you can sort of turn on and turn off per request, but it's just nice to sort of have that capability. That way, if you should be spending time on the pandas code that's doing the transformation from JSON to pandas array, or is it actually the model itself that's taking extra time. So I didn't show the version of the REST API for deploying, but here's the version of the REST API for the actual prediction. And all you would do really is just change from predict to deploy, and it's essentially the same thing, except that you're not passing any payload with it because there's no input. It's just the actual model bundle itself. And so here's another version here using REST API, and we get, again, we get a similar REST answer right there. Okay. So how are we doing on time? 9:30. I do want to leave time for questions too, so be prepared. We didn't get a lot of time for that the last time. So here's a Sidekit. And again, it's the same, 5 or 6 steps here. Let's let's see, yeah, so training a model. So this is one where we actually, we're using a model. So this is Sidekit, and this is training the model here. So that's where you see the fit. Let's see, here's a model initializer. So here's a case where our PIO model, which is sort of this wrapper around your scikit-learn model, it's just delegating in, like whenever you call predict on your on the PIO model, which is this wrapper, it's just going to delegate into the scikit-learn. And we had added that extra flexibility. There was a couple of use cases where people actually had multiple models here, and so it wasn't obvious which model should we be calling the predict method on. And sometimes it wasn't even just the predict method. Sometimes they wanted to call predict_proba, right, where it brings back the probabilities and not just the actual like classifications, for example. So in order to like support those use cases, we are just taking this wrapping approach, and yeah. So, but as part of that, you have to at least initialize the two underlying models, or your underlying scikit-learn models. So here's the way to do that. So when you do initialize the PIO version, it's taking in, or yeah, then you can also unpickle your scikit-learn version as well. And predict, we were playing with that over the weekends. Yeah, so this is what I was saying. This is the actual delegation step. So it's calling self.model.predict. This is where you call predict_proba. If you wanted to change that method or do a couple predicts inside of here. Still doing the transformations as part of the predicts. Again, we're likely going to make these either pull these out and have them done on the clients. They actually do take up most of the time in these calls. So if the whole call is about 5 milliseconds. Each transformer call is about 2 milliseconds, and then so that's 4 seconds total, and then there's 1 millisecond left for the actual scoring. So the scoring stuff actually hasn't. It's been pretty quick. It's more just kind of getting the data in and out of JSON and some of the heavy lifting there. So classic serialization troubles. Okay, so yeah, and that would be, now let's go to deploy. There's a way to test the model locally too. Actually, you can test the model, and it would be run through similar to what would happen on the server. So you can kind of get the actual response, the expected response, and this is true. Just ignore the deprecation warning down here. But this is a good sign. This means that for this data, this is what that answer is what I'm expecting. So we have more confidence when we go to deploy it. All right. Okay. So let's go to deploy it. Okay. So what this did was this took the current model that was in. It took this model that we had trained, that is the wrapper on the scikit-learn model here, and it deployed all of these assets out to the deployment server. It installed any of the requirements txt, things that were specified in there, and now the environment is ready to go. And we could do some predictions. Let's go to the predict. Okay. Let's do a predict 5. Just give it a quick little load test. Okay. It's like consistently, 12, 13 milliseconds, something like that. We don't yet have the breakdown. The code hasn't been committed that tells you where time's being spent, but that will be there soon. Definitely by the next time we talk. And here's predicting with the REST API. There's a similar answer. Let me show, mentioned the, so there's Spark, which model do I have here? And not much setup required there, training. So I think I already have this one built. Let me go to deploy it. See if it deploys. Okay, so that, yeah, this was trained with the census model within Spark ML. And let's run a prediction. See if this looks all right. I can't remember if I tested this before the talk, or if I broke it. Yeah, okay, it's working. So here it's predicting, it's returning back, based on some set of input. I can show you guys the input real quick. It's in this data directory. It's a test request, and it's just, a bunch of things you'd expect to see as part of the census inputs, and we're trying to predict if it's less than 50,000 is this person's income, or greater than 50,000. And so this particular case, it's less than 50,000, gives you probabilities for each. So pretty high confidence that it's less than 50, pretty low that it's greater than 50. So feeling good about that score. And let's do a quick mini load test. So it looks like the first time in, it was, I had to do some stuff, allocate some objects, that kind of thing. And then it slowly settles. Yeah, so now it's down to 15 milliseconds, something like that. And here's the version with Rust. Similar answer. Probably put it timing around there. Huh? Okay. So let me show you guys a couple other things, some of the experimental stuff that it's working. It's just getting it to a point to make it demoable. It's forcing us to kind of, work with people and see what's working, what they like, what they don't like. Obviously, a lot of the boilerplate stuff that we've been working with, that's going to go away. Here's TensorFlow version. See how clean this one is. Yeah, it's pretty clean. So you've probably seen a saved underscore model.pb. This is the type of thing that you deploy out to TensorFlow serving, and that's kind of your saved graph. There's also, it looks like it didn't get copied over here. I'm still finishing up this implementation for the demo. But you would have a variables like checkpoint file in here that would have the latest values that will get burned into the model during the actual prediction side. So, but similar kind of thing. If you look at train model, I've been doing a lot of work in here trying to make this quite a bit simpler. So you're going to see some stuff commented out, which is why it's not at the root level just yet. But yeah. So again, we're just pickling, giving it some sample data here, just making sure everything's sane and cool. And then deploying is done the same way. So that should look familiar, saying, one thing about TensorFlow serving, it does not like alpha. It will only take ints for the version numbers. So you have to kind of be careful. I've been purposely using alpha numeric for the other ones. To sort of encourage the use of, Git hashes and things like that versus just numbers. This is one limitation that we definitely plan to work around because we want the ability to use GitHub hashes instead of integers. The way TensorFlow serving currently serves, if it sees two models that it could potentially serve that are in the same folder structure, it's going to choose the one with the higher number. And that's just a particular version policy that is used out of the box that can totally be replaced. And but yeah, that's one big limitation. That's one reason why you don't see like a V in front here. So it's definitely not like the end of the world, very simple and straightforward to fix. It's just sitting down to actually do it. So PIO deploy, same kind of thing. It's going to bundle this up as a tar.gz. It's going to post it to this particular, so here the structure that we're doing is there's this API, this REST API, and this is the model API. In this case, it's the model predict API, and then it's the type of model. It's some like generic namespace. If you can assign any meaning to it that you want. Namespace could be the particular engineer's user name. That way, one model server can serve many different models, versions, types, and even namespaces. So I see people use the namespace instead of default. They would use the specific project name, for example, so that on their shared dev server, they're not all, kind of really overlapping with each other. And but yeah, and then it would be the name of the model, which in this case is TensorFlow_linear, and then it's /1, which is the version. So that now becomes the endpoint, and we can go, and I think the training side of, or the prediction side of this one's busted, which is unfortunate, but let's see, did I get one working? No. Oh yeah, I still have to fix that error. Okay, so that's gonna get fixed later today. And one other thing I wanna show, so for example, here's an example of, okay, so this is actually generated code. This was, so yeah, this was not manually generated. This was automatically generated based from a Spark ML model. So this is linear regression. It's the, what is this one? Oh, this is Airbnb, right? And so we trained it in Spark using Spark ML. We then, from there, we then natively generated Java code. And, it just literally generates this like Java string here. This then, when this gets pushed to the Java-based model server, the Java-based model server generates a Java class file on the fly. And as long as there's this like predict method, and as long as there's the initialize method, and it follows the signature that the model server expects, just two small things, you can then deploy this in a like serverless fashion. And so we have just the generic Java like runtime, and when it gets source code, it's going to compile it. When you upload it, you give it a name, and that's the part I don't have flushed out here. I have to go through and do that, 0, 0, 0, 1, 0, 2. I have to copy and paste those in here for the 5 notebooks, just to show people, and then also show the step of how we went from Spark to the native Java code. So I've done some actually comparisons where like we use PMML, for example, from Spark ML, and compared the performance to this native generated Java code. With the size of the model we were using, they were actually pretty similar, and that's a testament to the JPMML runtime, which is very, very well written, has a lot of optimizations built into it. And what we're trying to prove is how far off is the JPMML runtime from actually running full native Java code. And again, the Airbnb model isn't huge. It's bigger than just kind of simple linear regression, but the performance was actually pretty good. So kind of makes us realize maybe like we don't have to spend too much time on this native code generation side of things, but just giving people the ability to do it, and maybe their model could be faster. So yeah, kind of cool. And then at some point we'll be generating the NVIDIA PTX kernels, so and could actually run at native GPU speeds. Also, C++ runtime is coming very soon. We've got one particular customer that's a very heavy C user. We've got some sort of early prototypes of that, but not enough to stick out into the demo server. Okay, and I think that's it. Keep an eye on this community stuff. I've got it tied into auth 0 here, which is what I'm seeing a lot of people using. So it's support, you know, you can get in any way you want here. You don't have to give me your password. You don't have to give me anything. Just hop on in. You can use GitHub, you can use Facebook. And because this is Community Edition, all the URLs here have community in them. So this is a shared environment. So keep in mind, don't put anything sensitive out here. This was one technique I saw Databricks use early on when I was with them, where, you know, it wasn't the most ideal, it wasn't the most isolated, but it got people on here using their product and seeing some of their features. And what's cool about this too is that any links from here on out, if we want to share them with your friends, you know, these are all going to work. They're all have the same community sort of username here, right? So yeah, and I think that's it. Put some people, anyone have their hand up there? Let me check the chat. Where is the chat? Okay, so if you guys want to paste anything in, any questions, please paste questions here. Make sure you select all panelists and attendees so we can all see it. Quick shout out too for, we've got this workshop coming up. I actually have 2 workshops I've been doing. I'm doing one for the O'Reilly folks, high performance TensorFlow in production. You have to be a Safari member for that. I just talked to them last week because a lot of people were complaining that the classes are all filled up and that they signed up for Safari just to get access to this class, and now they you know, feel slighted and all that. So I begged O'Reilly to open up some more dates, which they were certainly more than happy to. They just wasn't sure about my schedule and things like that. So yeah, they're definitely going to open up. Usually it's a Friday or a Thursday. It's 3 hours, and we go pretty quickly. And it's pretty much end to end. We train the TensorFlow model. We strip it of anything unnecessary that's needed for like deploying the model, and we then deploy it. We then load test it, and we have a lot of fun along the way talking about some cool optimization techniques. So these are all techniques that will be buried behind the like deployment for PipelineAI. So when you use like PipelineAI or like DeployAI specifically, you would upload the model just like I was showing you guys, and it would then do these like optimizations for you, and even go as far as return you multiple URLs for different styles of like optimization, right? And this then lets you push out your canary directly from Jupyter out to production, and then will very clearly show you metrics, not just system metrics, but also, so not just things like how many predictions per second and like average latencies or 99% latencies and things like that, but will also show you the like predictive like comparisons between your current cluster, that has maybe 1,000 instances, and your like canary cluster that has one of these instances, and you're sort of sampling input data as it's coming through. You're then comparing it on both the canary and the normal cluster, and if and then this is part of automated canary analysis is the term. It's a term that like Netflix like uses heavily. They typically are using system performance, so things like Java heap size, and if anything is sort of out of whack, that gets highlighted in a UI that can be directly accessed through Jupyter. So just sort of giving data scientists again, right, like giving data scientists the data, the metrics that they need, and the ability to do their own experiments. Some future things coming along here are the concept of an experiment. That's the next extension of deploying models, is you'll be able to deploy experiments, and those are just going to be groupings of models, for example, and you would give certain percentages to each different model if you're trying to do some like A/B testing, and yeah, of course, multi-arm bandit testing is kind of the holy grail, using some like reinforcement learning concepts. So all that's going to be supported and available. in the tool as we go along. So a couple of people asked about the advanced edition and some of the advanced features there. Let me see here. Oops. I think I have advanced edition. Yeah, so here's some of the native CPU and GPU. Oh, the big thing with, yeah, so for the advanced edition, that's going to contain the experimentation stuff. And also have some of these more advanced features like the automatic traffic shifting. So, you know, imagine you want to save some costs, and imagine you're currently running on spot instances. You're doing predictions by like Amazon spot instances, and then suddenly you lose all those instances, and now it's actually cheaper to serve your models out of Google, for example, right? And so Google Cloud now is now currently the cheapest for the next hour, so let's shift our traffic over there, and you now sort of have infinite, you know, ways to deploy and you know, mix and match the different clouds, or maybe it's cheapest running on your own data center during the day, but you still want the ability to scale on a cloud, you know, during peak times, right? So seen a couple of cases like that are popping up. Yeah, there's some upcoming, you know, like training events. This is some of the O'Reilly stuff and some of the other stuff that we do. We also have a meetup, coming events. We have this global meetup here that we just hit. I think we're up to 18,000 people globally. Oh yeah, here this is 20,000. Maybe we hit 20,000. This thing's been growing like crazy. So you know, I've been picking up meetups or starting meetups in other cities, kind of revitalizing them a little bit, and you know, getting some more activity around them. So it's been good to see. I'm always looking for people in each of these cities to kind of facilitate. So if you want to look, it's the Advanced Spark and TensorFlow meetup. And we have all the archives here, videos and things like that, SlideShare. One thing to point out too is in the lower right down here is, sometimes it gets covered up by the help thing, but there's LinkedIn, and there's our SlideShare and YouTube and Meetup, and GitHub repo. So some stuff on performance that you might want to keep an eye on, dashboards and Viz. Cool stuff here. So these are, so you know, picture when you deploy your service, you get back one little segment of this, you know, like this metrics page where you can roll over, you know, the model in production, like inside of Jupyter Notebook, and this will pop up and kind of give you, you know, real time, right, like showing you how this model is performing. And then we would have comparison screens as well too, to you know, show any of the like canary analysis and things like that. So stuff's coming together over here. I appreciate all the feedback everyone's given. There's a lot of familiar faces on the line here. So any questions, guys? GPUs are coming soon, I promise. Okay. Look forward next week or next month will be, I'll get Christian back here, and I'm going to try to get actually one of his other buddies. There's a couple guys from the Funktion and Fabricate team within Red Hat that are doing some really cool stuff. There's this other project too. I didn't get a chance to mention this. Istio. If anyone has worked with the Netflix project Zuul, Z-U-U-L, it's the ability to do sort of intelligent request routing. Yeah, I don't know where they got these images from. This is like kind of a silly marketing thing there, but they actually just had a really good blog post, and I think they're due for a second one. Canary deployments using Istio. So yeah, this is exactly the technology that is really currently being built on top of to handle all the Canary deployments and all of the traffic shifting and, you know, things like that. So yeah, this Istio is, there's a lot going on here. There's some good docs. It's, you know, one of those things, there's a lot of moving parts and not everything works right out of the box, so you kind of have to like poke it and play with it. But there's quite a bit of support. So there's support from IBM, support from, I think, Microsoft. So it's more than just the Red Hat guys. But yeah, very, very Kubernetes aware, very like autoscale aware. And has these concepts of rules, and you can assign percentages to the different routing rules. And yeah, so that's essentially to send 10% of the traffic to Canary V2. Could set 9 to 1, all that kind of stuff. Or yeah, like give it the weights here, 90%, 10%. Yeah, auto scaling aware. The other one too, this is something that has been on my radar to get to work is, what's it called? Spinnaker. If you guys have heard of Spinnaker. Spinnaker IO. This is the next generation Asgard. If you remember, Netflix was kind of a pioneer back in the day where like the Amazon console was too restrictive, and Netflix being Netflix, they wanted to build tooling that let developers and data scientists and stuff get their artifacts into production quickly without a whole bunch of sign off and Jiras and so Spinnaker so they built this tool called Asgard back in the day. Spinnaker is the next generation of this and is now across all of the major cloud providers. So it says multi-cloud here. Companies like Microsoft, like Oracle, like Google, they have dedicated teams now within their cloud organizations that are building plugins and filling in any gaps. And it's still Netflix that's building most of the like Amazon specific things, right? Like mainly because they're the main people behind it and they're kind of pushing the limits. And I think the Amazon guys help if they have to get to certain things that they can't get to through the normal APIs, but it's mostly Netflix doing the Amazon engineering side of it. Very Kubernetes aware. That's actually the one problem, the one piece I've been having problems getting working. All of my Spinnaker community friends say it's easy, and I'm the one doing something wrong. So I just have to sit down, or have like one of my guys sit down and just crank it out. So I've started it a few times. There's a couple easy ways to install it. Spinnaker gives you the ability to go from Jenkins, for example, and actually deploy the artifacts and build the AMIs and build the Docker images and handles the Kubernetes. That's the true pipeline that is in the name PipelineAI, right? So for now, we're focusing on the deployment side of the pipeline, and at some point, depending on how the product fits into the market, we would then back up and start to tackle more and more of the earlier stages of the pipeline. And Spinnaker is definitely high on the list, and it's mainly because of the cross-cloud support, mainly because it's built on Kubernetes, which we know very, very well. Uses best tools like Jenkins for the continuous delivery and continuous integration, and and I just have a lot of people that have hit a lot of the bugs and have solved a lot of the bugs in my personal community, so feel comfortable using that. Okay, we're right up to 10, and if you guys have any questions, I'll put my that's the Pipeline AI help desk, and we all see it. So any questions, just shoot me a note there, and I'll talk to you soon.